Many times in books or sometimes in school you might have learnt that deceleration means negative acceleration, but that is wrong. Deceleration is not the same as negative acceleration. First, let's understand what deceleration means. Deceleration is slowing down of the speed. Deceleration has to do with speed. Acceleration has to do with velocity. Okay, it is the rate of change of velocity. There are three kinds of accelerations, three situations where you can talk about acceleration. First, when an object is speeding up, right? So when it is speeding up, let us say it starts with a speed of 5 meters per second, it becoming 10 meters per second, speeding up, we say that object is accelerating. This most people understand as acceleration. Then when an object is slowing down is also acceleration, right? So if I was going at 10 meters per second and I slow down to 5 meters per second, that is also acceleration. But it also has two more names. It is also called deceleration. Okay, it's not deacceleration, it's deceleration. Now, slowing down and deceleration mean the same thing. There is a third word called retardation, which also means the same thing. So what is the meaning of deceleration? Slowing down, reduction of speed. The slowest you can get down to is 0. So you cannot decelerate from 0. So you can have 10 meters per second and you can go to 5 to 0. But after you get to 0, you cannot go, you have to basically increase your speed. With acceleration, it's very different because once you are at 0, you can continue to be in the negative direction and you have an acceleration. Deceleration is not the same as negative acceleration. We'll see that in a minute. The third way in which you can talk about acceleration is when there is a change in the direction. Okay. Now you can have change in direction with slowing down or with speeding up. But basically if you have change in direction, you're talking about acceleration. You can also move with a constant speed but changing your direction. So suppose I started doing this, but I was moving with constant speed. I have an acceleration, but I don't have a deceleration. Okay. If I'm speeding up, I don't have a deceleration. Usually people say, are you decelerating or are you accelerating? But that's a terrible statement because that says acceleration and deceleration are opposites. Suppose I ask, are you a girl or are you a human being? It means that a girl is not a human being. Are you a boy or are you a human being? That means the boy is not a human being, right? You can't say deceleration or acceleration. You should say deceleration or speeding up because these two are opposites. What is the opposite of acceleration? No acceleration. Acceleration involves this and that. One of the things, all of them are basically acceleration. So when are you not accelerating? When your velocity is constant. So opposite of acceleration would be uniform motion or uniform velocity. Okay, or rest. Well, rest is also uniform velocity. The opposite of acceleration is not deceleration, it is uniform velocity. So generally keep that in mind. So first of all, acceleration and deceleration, they are not opposites. Second, deceleration is not negative acceleration. Why am I saying it's not negative acceleration? Let us take an example. What happens typically is people only consider objects moving in the positive direction. Now direction is set by us. If I was accelerating in this direction and this direction was positive, then we will say acceleration is positive. But instead if I chose this direction as positive, I will say acceleration is negative. Acceleration comes with a direction. Deceleration does not. Deceleration is a number. Okay, it is not something that it's talking about speed, it's not talking about velocity. So whenever you say you have deceleration, you will never say you have a -3 meter per second square deceleration. You are just giving the magnitude of the acceleration and you are saying that this fellow is slowing down, the speed is coming down. Okay, let us take an example. I am going to take 4 situations and for all situations I am going to assume that this is the positive direction. Now imagine I have a car or something or a bike. Now this bike I'm going to basically go that way. I can also take my bike this way. Just because that's a positive direction doesn't mean I can't move in this direction. So suppose my bike was basically going this way. Okay, so let's say I was sitting on this bike and I was riding this bike there. Now this bike, let us say, starts with 5 meters per second, and then it's going to basically speed up to 10 meters per second. What will you say about this situation? You will say that the bike is speeding up. So this is speeding up, correct? Is it accelerating? Yes. What direction is the acceleration? The acceleration direction is that way. That's why 5 has become 6, 7, 10. It is increasing that way, right? So the acceleration direction is like that. That is positive. Therefore, I'm going to say acceleration positive. Is there a deceleration here? No deceleration. Okay. So basically let's add that also. No deceleration. So people look at these two and say, positive acceleration, no deceleration. But hold on. Let us say that this fellow was moving in this direction. Okay. And was starting off at 10 meters per second and is come down to a speed of 5 meters per second. What will you say now? Slowing down or speeding up? Slowing down, right? So this fellow is slowing down. So it's slowing down will mean deceleration. What is the direction of acceleration? Is it that way? No, because then 10 would have become 11, 12, 15. It's not going to get to 5. So acceleration would have to be in this direction. But that is the positive direction. I have chosen that as the positive direction. Therefore, this acceleration should be negative. So we'll say acceleration negative. So people look at this and say positive acceleration, no deceleration, negative acceleration, deceleration. So they conclude deceleration means negative acceleration. But hold on, science does not stop with just two things, right? What about this guy not moving this way but going that way? So you have to consider more situations. So let us take a situation where this fellow is going in this direction. My bike I can drive this way. So if I start at, let us say, 5 meters per second and then get to 10 meters per second, I am going in this direction. Am I slowing down or speeding up? Speeding up. I started at 5, I went to 10. Slowing down and speeding up has to do speed, not with velocity. I started with 5, ended with 10. Acceleration is in this direction. But wait a minute, if that is plus, what is this? Minus. So I have a negative acceleration, but I am speeding up. Do I have a deceleration? No, because you are speeding up. How can you have deceleration? No deceleration. Notice this. Negative acceleration, no deceleration. Negative acceleration, deceleration. So you cannot say whenever you have negative acceleration, you have deceleration, because you have negative acceleration and deceleration, and here you have negative acceleration and no deceleration. Negative acceleration, no deceleration, speeding up. Negative acceleration, deceleration, slowing down. Here you are speeding up and you have acceleration that is positive. Now I have another option, right? So I can take the same vehicle and I could be going at 10 meters per second, and after some time I am now going at 5 meters per second. Am I slowing down? Yes, right? 10 to 5, I am slowing down. So when I am slowing down, basically this is deceleration. I am slowing down. What is the direction of acceleration? Is it this way? No, because if it was this way, 10 would have become 11, would have become 15. No, it has to be that way. So acceleration direction is that way. But that way is positive. So acceleration is positive. So let us look at the 4 cases. Positive acceleration, no deceleration. Positive acceleration, yes, there is deceleration. Negative acceleration, no deceleration. Negative acceleration, yes, there is deceleration. So if you have negative acceleration, should you always have deceleration? No. If you have deceleration, this is deceleration and this is deceleration, right? Does it mean acceleration is negative? No, here acceleration is negative, here acceleration is positive. What is really true? Because acceleration, negative acceleration is deceleration is a very, very common statement. It is wrong. Point blank wrong. Okay. So then what is correct? If the direction of my velocity, initial velocity, and the direction of acceleration, they are opposite, then the object is decelerating. Let us see here. Initial velocity, acceleration. Initial velocity, acceleration, decelerating. Initial velocity, acceleration. If they are pointing in the same direction, you are speeding up. Pointing in the same direction, you are speeding up. So actually, instead of saying deceleration is negative acceleration, we should say if you are decelerating, your velocity and your acceleration must be in the opposite directions. If you are speeding up, don't say if you are accelerating, this is also acceleration, right? Opposite of deceleration is speeding up. So if you are speeding up, velocity and acceleration are pointing in the same direction. Whenever velocity and acceleration point in the opposite direction, this is my velocity. Let's say this was my velocity and my acceleration is pointing in this direction. It is basically making this arrow smaller, which means the length of this initial velocity, acceleration, my velocity is becoming smaller, which means I am slowing down. You are decelerating. So deceleration means velocity and acceleration are in opposite directions. Then why do you learn this? Because many books assume that you are moving in the positive direction. Always that they assume that direction you are moving is positive, which is very confusing because sometimes you may be going that way, sometimes you may be going this way. So for example, I took this ball and I threw it up. The ball went up and then came back down. So if I draw it, let us say I draw it here, the ball went like that and came back down. So when it was going up, velocity was this way, acceleration was this way. When it is coming down, velocity is this way, acceleration is this way. Can you see that the acceleration has not changed at all? You should use one direction. Let's say this was positive, positive acceleration. But here velocity was opposite to acceleration. So from here till there it was decelerating. From here to there it was not accelerating, speeding up. It was accelerating throughout. It was of course accelerating here, but it was accelerating here also. So here it was decelerating, there it was speeding up. So the ball goes up, it is slowing down, then it is speeding up. But it is uniform acceleration. Here acceleration was downwards, topmost point it was downwards, again there it was downwards. So uniform acceleration is very simple. Acceleration points in the same direction. So therefore free fall motion, don't break it up into two pieces. Don't study it as when it is going up, positive is upwards. When it is coming down, positive is downwards. Don't do such things. Choose one positive direction for the whole motion. Downwards positive, acceleration downwards, acceleration downwards, acceleration positive. If you chose upwards positive, acceleration is still downwards. So that means it's negative, negative. It is uniform. It does not change. Velocity changes direction. Acceleration does not change direction. Uniform acceleration maintains the direction. So it's very simple. If you thought in terms of acceleration, physics, we don't try to use deceleration. No formula will involve deceleration. But day to day when people talk about deceleration, they are talking about slowing down, okay, reduction in speed. So therefore they use the word deceleration, so it will come in problems. But when you use it, remember, if deceleration is there, velocity and acceleration must be in the opposite directions. So deceleration is not the same as negative acceleration. Acceleration, negative or positive, depends on which sign you took as the positive direction and what the direction of acceleration is. Deceleration depends on whether you are slowing down or speeding up. So I hope that difference is very important and keep that in mind. When do you have deceleration? When velocity and acceleration are pointing in the opposite direction. Acceleration includes speeding up, deceleration, changing direction. It includes everything. Okay? And if you don't have acceleration, that means you're moving with uniform velocity. So keep these points in mind, and it's very, very important to recognize that deceleration and negative acceleration not the same. Negative or positive depends on the direction you choose. So if I say acceleration is like this is positive or negative, depends on whether I chose this as positive or that as positive. I can make this negative or positive. With deceleration, the concept of a negative deceleration does not exist. There is no direction to deceleration. There's a direction to acceleration. Okay. So if I tell you an object is decelerating, it means the object is slowing down. If velocity is this way, acceleration is that way. Velocity is that way, acceleration is that way. That's what you will conclude. Okay. So I hope this is very, very clear. Keep this in mind.